Welcome to another math tutorial video where this time we will be looking at division with rational exponents, which is the same as IXL M3. So this one actually is going to be pretty quick, I think. So let's look at an example. Jump right in. So let's say we're going to be simplifying, and that's going to be the same rule for all of these. So I'm just going to only write it once. So on this one we have b to the 3/2 over b to the 5/2. Now, just like with multiplication, if I have the same base, well, with multiplication I would add exponents. But for division, if I have the same base, I will subtract exponents. Now, one really important thing to note, if I did 3/2 is on the top, 3/2 is smaller than 5/2. So if I did 3/2 minus 5/2, it's going to give me a negative 2/2. Remember from the last part how we don't want any negative exponents? Well, one thing to know here, let's use this color. This is the largest. So since my largest is on the bottom, that means I'm going to basically keep my b's on the bottom. So change it back here to black. So if I did 5/2 minus 3/2, so we're going to have 1 on the top over b to the 5/2 minus 3/2. So that is going to be 1 over b to the 2/2, which basically 2/2 is 1, so it's going to be 1 over b to the first, or just 1 over b basically. That's all we really have to do on that one. So let's look at another one. So on this one, let's say that we'll have 2 to the 9/4 over 2 to the 5/4. So on this one, my largest is on the top. 9/4 is greater than 5/4. So that means I'm going to keep my number on the top. So hold on, I think this is supposed to be a z, not a 2. So let me fix that. I'm sorry about that. This is what happens when you can't read your own handwriting. You know, that's kind of a problem. All right. So that's supposed to be a z. In math, I always never liked it when problems would use z's, because my z's end up looking like 2's, and then I get confused. But anyway, here we are. So we're going to keep our z's on the top. So I'm doing z to the 9/4 minus 5/4. We're subtracting. And we're putting all that over 1. But is the 1 really necessary on the bottom? No, it's not. So we're going to have z to the 4/4, which is z to the first. And of course the 1's not necessary, so our answer is just z. Pretty easy, right? Let's look at another one. All right, let's say that we have b. So we have b to the 11/6 divided by b to the 7/6. Okay, so this one's written a little bit differently. So to make it a little less confusing for myself, I'm just going to write it as a fraction. So, because that's what we're more used to. But you really don't have to do this step. So I know that my first one is the greatest. 11/6 is greater than 7/6. So since I know that the top is the greatest, we're going to keep our b's on the top. So it's going to be b to the 11/6 minus 7/6 over 1, but that's not going to be necessary. So it's just going to be b to the 4/6. And as our final answer, 4/6 will simplify. They both divide by 2, so it's going to be b to the 2/3. And if you didn't know how I got that, basically I just divided the top by 2 and divided the bottom by 2. So that ends up giving me that. All right, just one more example. I think we're pretty good on this. So let's say that we have d to the 3/4 divided by d to the 9/4. Really the same thing. So let's just write it as a fraction. So d to the 3/4 over d to the 9/4. Ooh, all right. So on this one, however, the bottom 9/4 is greater than 3/4. So that means we're just going to put a 1 on the top, and we're going to do all of our action on the bottom. So we have d to the 9/4, subtracting our exponents because we have the same base. So 9/4 minus 3/4. So it's going to be 1 over d. Okay, 9 minus 3 is 6. So that means I have 6/4. So d to the 6/4. And well, 6 and 4 both divide by 2. So my final answer is going to be 1 over d. 6 divided by 2 is 3. 4 divided by 2 is 2. So 1 over d to the 3/2. And that's really all we have for this one, y'all. So if you have any questions, email me, whatnot, all the good stuff. And I hope you all have a great day and good luck.